Good afternoon, ladies and gentlemen. In this short video, I'm going to be doing the practice problems for PracC in Chapter 20 about transformers. So these are on page 741. Let's start with number 34. 34 reads, a transformer is used to convert 120 volts to 9 volts for use of a portable CD player. I don't know if anybody uses CD players anymore. If the primary, which is connected to the outlet, you're plugging it into the wall, has 640 turns, how many turns does the secondary have? Okay, so always, first you want to rewrite the problem on what the given is. So here's my given. My given is I have 120 volts and it's going to be converted to 9 volts. And the primary, which is on the 120 volts, that's the primary. This is the secondary. That's a 1 with the little 0, like so. So the question is, how many turns is on the secondary coil? All right, so we're just going to take our conversion, our equation, and however it comes out. Let's see, I'm going to say V1 over V2 is equal to N1 over N2. Then I realize, I don't want to have to do two operations. I want N2 on top because that's what I'm solving for. So I'll say, okay, V2 over V1 is N2 over N1. And I want to solve for N2. That's what we're asking for. Now, it doesn't matter if you use uppercase or lowercase. So I'm going to multiply N1 to both sides, N1 to both sides. So that's cancel out. All right, so N1 is 640. 640 times my V, I've got V2, that's this side right here, is 9 volts divided by V1, which is 120 volts. 120 volts. And this is turns. I should have left the units on there. Turns, because my volts cancels out and I'll end up with number of turns. Okay, so let's see, what do we have here? I got 640, can't see that, times 9 divided by 120. And I get 48 turns. I get 48 turns. And this should make sense because I start with 640 and end up with 48 turns. So I have fewer turns, so I'm going to get a smaller amount of voltage, which is why it makes sense. We got 9 volts. All right, so that takes care of number 34. Let's look at number 35. Suppose a 9.00 volts CD player. So again, I want you guys to start paying attention to significant figures. You have to give them at least as many significant figures that they give you. Suppose a 9 volt CD player has a transformer for converting current in Great Britain. So you went over to Great Britain in England and you want it to work. If the ratio of the turns of wire on the primary to the secondary is 24.6 to 1, what is the outlet potential difference? All right, so we write what they give us. Here's what they gave us. They gave us that V is 9 volts. So this is our outlet. This is how much we want to come out. Okay, because we take our little CD player and we're going to plug it into the little outlet, on the wall, So we want to make sure that we end up with 9 volts here. So the question is, how much voltage do you have here on the wall when you plug it in? All right, so they give you the N1 to the N2, right? Because it said from the primary to the secondary, the N1 to the N2 is 24.6 to 1. So what's V2? V1. So what is it? We're going to call the wall here V1. All right, so V1 is what I want. So I'm going to say V1 over V2 is equal to N1 over N2. I want V1. So in this case, I'm going to multiply V2 to both sides. Multiply V2, multiply V2. So my V2s cancel out and I'm left with V1. All right, so let's see. N1 is 24.6 to 1. So this is 24.6 to 1 times V2, which is 9 volts. 9 volts. Okay, so these are turns and turns. I'll put a little turn and turn. So those are going to cancel out and I'm left with volts. Okay, so what do I end up with? I'm going to have 9 times 24.6. and I get 221.4 volts. That's a 4. So that's about 221 volts. Okay, because they did give me 9.00, so I needed 3 significant figures. There's my 3 significant figures. This is 9.00. Okay, so again, we're using the same correlation, just making sure your voltage, primary to secondary, is consistent to your number of turns, primary to secondary. All right, so let's do the next one, which is number 36. Number 36, a transformer is used to convert 120 volts to 6.3 in order to power an electric train. If there are 200 turns in the primary, how many turns should there be in the secondary? So let's see, I should have rewritten this. Are ready for us? There we go. Okay, so I realize, okay, we have 120 volts. It's being converted to 6.3. The primary is 210 turns. I'll write it down. So the question is, how many turns in the secondary? All right, so let's see, that's going to be, this is the primary, and here's my secondary. Okay, so let's do V2 over V1 is N2 over N1. And now we solve for N2. So I'm going to be multiplying both sides by N1. Okay, so N1 is 210 turns, 210 turns times V2, which is 6.3 volts, all over V1, which is 120 volts. So my volts cancels out and I end up with turns. So what do I get? I'm going to have 210 times 6.3 divided by 120 volts. And I get 11.025 turns. So that's pretty close in terms of significant figure to 11 turns. So it's 11 turns. So we're always using the same correlation between the turns and the voltage. You may want to have the 2's on the top. You may want to have the 2's on the bottom. As long as you're consistent for turns and voltage. Not true with current, because current is the inverse. All right, let's do the last problem. Here's the last problem. Here we go. The transformer shown in the figure below is constructed so the coil on the left has 5 times as many turns of wire as the coil on the right, which is not consistent with what they have here. So I think there's a typo there. So I go with what they actually show here. I have 60 turns here and 3 turns. So that's not 5 times. All right, if the input potential difference across the coil on the left, what type of transformer is this? I don't even think you need to say anything about the potential difference. You should be able to, they're just saying the one on the left is the input. Okay, they're saying the one on the left is the input and the one on the left is the output. We want to know what type is it. Is it a step up or is it a step down? Hopefully you'll notice that when you go from 60 to 3, it's definitely a step down. Okay, so that one's definitely a step down. Let's say I wrote it over here. Is it a step up or is it a step down? It's a step down. All right, then they say if the input on the left is 24,000 volts or 24 kilovolts, what's the output potential difference? All right, so now we know that V1 is 24,000 volts. And I just want to make sure you guys are starting to get used to kilo, whether it's ohms or meters or volts. Then what is V2? All right, so here we go. Same correlation. I'm going to write V2 over V1 is N2 over N1. And V2 is the one that I want to solve for. So I want to isolate that. So I'll multiply V1 to both sides. All right. So we can just plug that in. Let's see. N2 is 3. So 3 over N1, which is 60. This is turns, turns. So my turns cancels out. All that times V1, which they just told us is 24,000 volts. 24,000 volts. Okay, looks like it's going to be a step down because 3 over 60, well, we already decided it's a step down anyway because we're going fewer turns. 3 over 60, those less than 1. So let's see, I got 3 times 24,000 There it is, divided by 60. There we go, and I have 1200 volts, or 1.2 kilovolts. So I went from 24 kilovolts down to 1.2, and all I had to do was change the number of turns, the primary and secondary. So again, all these problems are the same thing. Their V2 over V1 is equal to N2 over N1, or if it's more convenient for you, V1 over V2, N1 over N2. The ratio of the turns is proportional to the ratio of the input to the output voltage, or the primary to the secondary is proportional to the primary or secondary turns. And that's all we have for this one. So just let me know if you need any help. See you later.